In the previous video lecture, I had explained about the types of frequency distributions with a simple problem along with steps and important terms. Now, in this part, I am going to discuss about class limits, class boundaries, how to calculate magnitude, what are the different types of class intervals with few examples, and also I'm going to explain about open and closed-ended series with examples. Now let me first show you for the given class limits what will be its class boundary for the given table examples. Now dear students, class limits are given, class boundary we need to find. I already told you the rules for setting class boundary. If there are only one decimal place, we need to use only 0.0. If there are two decimal places, we need to use 0.00. If there are three, we need to use 0.000. And if it is 4, we have to use 0.0000. So this is a simple rule how to do. I have mentioned in the center. So let me read it for better understanding. When subtracting from the lower limit and adding to the upper limit, use as many zeros after the decimal point as present in the limit. So if there are two decimal places in the lower limit, then subtract 0.005 and add accordingly. Now, let me use my stylus pen and explain about how to deal with the first example as I'm going to take 24.25 and 34.5. So 24.5 is the lower limit, try to understand, and 34.5 is the upper limit. Now, I'm setting my pen and let me bring this example down as you can see. Now, first, how many decimal places are there we need to observe in the given class limit? There are only one decimal place. So what we need to do? We need to take the lower limit and reduce 0.05. Is that clear? And what we need to do with regards to upper limit, I'm mentioning U for upper limit, we need to add 0.05. So this is the simple rule we need to apply for the first example. Is this clear, dear students? How to apply? I will write in the class boundary for your understanding. I will write only once. Later on, you should understand with the other examples. Is that clear, dear students? Okay. Now, 24.5 minus 0.05. How much we are getting? We need to check with calculator. Or students, you can open your calculator and check what is the answer. Okay. Then 34.5 plus 0.05. How much we are getting? So for the first answer, we will be getting 24.45. Okay, this is the first one. And the second one, we will be getting 34.55. Is this clear to understand, dear students? So what we need to do, lower limit minus upper limit plus. Just to see how many decimal. If it is 1, just reduce 0.05. Okay, then you need to add in the upper limit plus 0.05. Anyway, I will show you the answer in the class boundary. by erasing this. Now, the answer for the first class limit will be 24.45 and 34.55. How do we get this? We need to reduce 24.5 minus 0.05. Okay, and upper limit 34.5 plus 0.05. That is the answer we have got with regards to the first class limit. Now, for the second class limit, what we need to do, again I'm explaining for better understanding. Lower limit, what we need to do, minus 0. We have two decimal places, so 005. Is that clear? And for the upper limit, what we need to do, add 0.005. So this is what we need to do with regards to the first lower limit, reduce as I'm rounding, minus 0.005. Okay, and for the upper limit, as I'm rounding here, we need to add 0.005. So is this clear, dear students? So the answer will be 24.345 and 44.455. So this is the answer for the second class limit. Now let me show you the third class limit. What will be the answer? Now for the third class limit, four decimal places are there. So you need to reduce first the lower class boundary with 0.405 and you need to add 0.405 in the upper limit. Let me show you so that you will understand. So first lower limit, we need to reduce 0.4 decimal places, okay? 0.0005. Then for the upper limit, you need to add 0.00005. This is clear. So if you apply this, the answer will be 38.45445 and 68.45455. So is this clear? I hope this example is clear. Now for the next one, 92.335 and 102.455. Can you try and tell me, dear students, what will be the answer? Yes, 92.3345 and 102.4555. So this is how you need to deal with class limit and class boundary as I've shown you as simple examples. Now let me explain what is magnitude, how to find magnitude. So the difference between lower limit and upper limit of the class interval is known as the magnitude. How to find? Let me give you a simple example. Now class limit is given. This is the question. You need to find class boundary and magnitude. How to find? Let me bring the first example down. So what you need to do, lower limit, try to understand there are no decimal places. When there are no decimal places, you need to minus 0.5 and upper limit you need to add plus 0.5. This is the upper limit. So is this clear? So 10 minus 0.5, how much you will get? 9.5. 19 plus 0.5, how much you will get? 19.5. So that is the answer for the first class boundary. I hope this example is clear. Same way we need to do for the second, that is 20 and 29. So 20 minus 0.5, 19.5. 29 plus 0.5, 29.5. So this is the second answer. The third one is 29.5 and 39.5. The fourth one is 39.5 and 49.5. So this is how you need to find the class boundary. Please remember there are no decimal places in the class limit. So you need to reduce minus 0.5 in the lower limit and add 0.5 in the upper limit. Is that clear, dear? Now, how to find magnitude? Magnitude is a difference between lower limit and upper limit of the class interval. Now, can you find 10 and 19 are there? 10 is the lower limit, 19 is the upper limit. So 10 minus 19, how much we will get? Yes, 9. Same way for the second one, 20 minus 29, 9. 30 minus 39, 9. 40 minus 49, 9. So this is the simple calculation to find the magnitude. How to find magnitude? To find magnitude, what you need to do? 10 minus 19. What is this 10 minus 19? Class interval. Can you see the class interval? Yes. From here only we are trying to find the magnitude. So I hope this simple example is clear. Let me erase for you. So this is the answer. You need to calculate with regard to class boundaries and magnitude. So I hope this simple example is clear. Now how to find class interval, class width? Now you need to take the difference between lower boundary and upper boundary of the class. Then only you can identify class interval. So how to find, let me bring an example. Okay. Now class limit, the same problem, we need to find class boundary. It is the same rule we apply. So 10 minus 0.5 and 19 plus 0.5, you will get the class boundary 9.5, 19.5. When you do for the next one, 19.5, 29.5. When you do for the third one, 29.5, 39.5. Fourth one, 39.5 and 49.5. Now, here we need to find class interval. So to find class interval, we need to take the items from class boundary, not from the class limit. Okay. So how to find the class interval? Let me bring the steps down. First one, 9.5 minus 19.5. How much are we getting? Can you calculate and tell me, dear students? We are getting 10. So this is the result you need to enter, 10. Same way, 19.5 minus 29.5, 10. 29.5 minus 39.5, we get 10. 39.5 minus 49.5, how much we are getting? 10. So this is the simple example to calculate class width or class interval. So I hope this example is clear to understand. Now, let me show you some examples with regards to the types of class interval. We have three types: inclusive, exclusive, empty. In inclusive, you can see the class limit which is having 4 to 9. If the problem states inclusive, you need to take 4, 5, 6, 7, 8 and 9. Okay? If it is exclusive, you need to take only 4, 5, 6, 7 and 8. The ninth one, what will happen is, it will go to the next class limit, for example like this. Okay, can you see down? It will go down like this. That is why we are taking only values up to 4, 5, 6, 7 and 8. So when I do the problem, inshallah you will very clearly understand. Now in empty, there will be no observations. So these are the different types of class interval we need to understand. Now let us understand what is inclusive class interval. So what are all the steps to be followed? I will tell you in brief here. Now in this method there are two extreme values. They are called class limits. Now, for example, 40 to 49, we are taking values starting from 40 to 49. Okay. The smaller limit is called the lower limit, and the larger limit is called the upper limit. So, can you see the smaller limit? This is the lower limit, and this is the upper limit. Both the limits are included while counting the observation for each class. That is why you can see the numbers are taken from 40 to 49. So this method is said to be inclusive class interval method. So this is the same example I have shown you here. So this method can be adopted in the grouped series in which there are no fractional values of a variable. So these are the rules to be followed for calculating with regards to inclusive class interval. Inclusive means include everything, starting from the lower to the upper. So this is the point to be kept in mind. Now, the second method is exclusive class interval method. Now, same way we have two extreme values we call class limits. The smallest limit, that is the smaller limit, is called the lower limit, and the larger is called the upper limit. Lower limit is included, upper limit is excluded. This is the point to be noted. Upper limit is excluded while counting. Need to be very careful. Okay. So if the class interval starts with 40 to 50, you include starting from 40 to 49 only. In this method, upper limit of the preceding class would be the lower limit of the succeeding class. Now, can you see this example? In this 40 to 50, you have taken starting from 40 to 49 only. Now, the next class, for example, 50 to 60. So the 50 which is remaining here, it will go to the next lower limit of the succeeding class. So this is the rule we need to understand while solving under exclusive class interval method. Now empty class interval, empty means there are no observation. So in this class interval which is having no frequency as well as there are no observations against this class interval. That is why it is said to be empty class interval. Now let me explain with regards to open-ended series. Now what is this open-ended series? By looking into the problem, one has to understand whether it is open-ended or closed-ended. What are the rules to be followed? Let me explain. Lower limit of the first class interval and the upper limit of the last class interval are not specified. Please try to understand. First class interval as I'm marking and the last class interval not specified. This is the rule you have to keep in mind. Okay. Now look at the example. Now I am marking this is the first class interval and this is the last class interval. So this is not specified. Can you understand here? This is not specified. I'm just writing in short. NS means not specified. That is why this problem is an example to understand open-ended series type problem. So now it is clear to understand. Also, the first class interval begins with words less than or below. So you can see here it is starting with less than, more than, or sometimes less than, or they will say below, more than, they will say above. So the last class interval ends with the words more than or above. So this is a simple example to understand with regards to open-ended series. Now what is close-ended series? Close means very simple, that is in the beginning and in the end it is closed. Nothing will be given. Either it is below or above, nothing will be mentioned. So all the class limits of the series are specified. As you can see, there is no below and above. So you can see in the first and last, nothing is mentioned. Everything is closed. Okay. So this is the example to understand with regards to close-ended series. There are no open-ended class intervals either in the beginning or in the end of the series. So this is an example to understand with regards to close-ended series. In the previous video lecture, I had solved some problems with regards to class limit, class boundary, class interval, and types of class intervals with simple examples. In this part, I will be discussing about broken-ended series, midpoint, cumulative frequency, types of cumulative frequencies with simple exercise problems. First, let me explain what is broken-ended series. Now you can see the examples very clearly with regards to values and frequencies as I am underlining. You can see there is no continuity in the values. When there are no continuity and the series are broken like this is an example to understand broken-ended series. So it is a combination of discrete and continuous. You can see this is the discrete and these are the continuous variables. So this is with regard to broken-ended series. Now let me make you understand what is mid-value, midpoint with regards to a simple example. Now, mid-value, it is the central point of the class interval which is exactly the middle of two extreme limits of the class interval. Now, you can see the class interval as I am marking. These are the class interval. From this, we need to calculate mid-value as I am highlighting. How to calculate mid-value? We have a formula. Lower limit plus upper limit divided by 2. It means I will do the first example. Lower limit is 10 plus upper limit is 19 divided by 2. So 29 divided by 2, you will be getting 14.5 as I'm marking in the mid value section. So I hope this is clear. So like that, the second one, 20 plus 29 divided by 2, you will get 24.5. 30 plus 39 divided by 2, you will get 34.5. 40 plus 49 divided by 2, 44.5. So this is how we calculate mid value from the class interval. Mid values differ with the difference in types of class interval. Okay. First, let me erase some items so that you can understand. So I'm erasing this part so that you can understand. Okay. Now it is clear. Mid values differ with the difference in types of class interval. So definitely it is differing in types of class interval. They lie halfway between the two extreme limits or boundaries as the case may be. Now, after class interval, we need to find, let me take my pen, we need to find class boundary as I'm highlighting in black. How to find class boundary? Lower limit, we need to reduce 0.5. Upper limit, we need to add 0.5. That is why you can see here 10 minus 0.5, 9.5. 19 plus 0.5, 19.5. This is how we determine the class boundaries. Lower limit, we need to subtract. Upper limit, we need to add. As already I have also explained in my previous lecture examples. So this is the formula to calculate lower limit plus upper limit divided by 2. Now, how to calculate magnitude? To calculate magnitude, we need to take class interval. 10 minus 19 will be 9. So 20 minus 29, 9. 30 minus 39, 9. 40 minus 49, 9. So this is how we calculate the magnitude. Class width, we take the class boundary. Do you see class boundary? I am underlining 9.5, 19.5. So 9.5 minus 19.5, we get 10. Same way, if we calculate 19.5 minus 29.5, 10. 29.5 minus 39.5, we get 10. 39.5, 49.5, we get again 10. So this is how we calculate width magnitude from the given examples. So from the given example, this is the procedure to calculate class boundary, magnitude, width and mid values. So I hope this simple example is clear to understand. Now we need to understand what are the meaning of class frequency, derived frequency, percentage frequency. Class frequency, as I told you, it is number of observation corresponding to a particular class. How many number of times it is occurring, we calculate and we enter the frequency. So it is also said to be rate of occurrence of a particular event or value relating to a particular class. Derived frequency, we have to calculate by using a formula. So as I am rounding here. So frequency density, it is the rate of the class frequency to the width of that class interval. So we need to take class frequency divided by width of the class. So width of the class we derive from class boundaries. The next one we need to know is about percentage frequency. It is the ratio of the class frequency expressed as percentage. Percentage means you need to multiply by 100. So how will we determine class frequency divided by total frequency into 100 as I am underlining the formula. So you can understand class frequency, derived frequency. In that frequency density, percentage frequency, I have a small practical example. Now I will show you and explain how it is done. So this is the example. So class interval is given, frequency is given. This is a problem. You can see class interval, I am rounding, frequency, this is a problem. We need to calculate frequency density as I'm underlining and percentage frequency. So this is what we need to calculate from the problem. So how to calculate? Step number 1, we need to make the total of frequency. Can you see the frequency? So this total we need to calculate. So this total comes to 50. Next one, we need to calculate frequency density. We have a formula, class frequency divided by width. So we need to calculate class frequency. How to find class frequency? Lower limit, as I told you, minus 0.5, upper limit plus 0.5. So we need to determine the class boundary. Then we need to find the width. Let me take eraser, erase these so that you can understand. Now class boundary, I am just writing CB. Just for understanding purpose I am doing. If you know clearly, directly you can do, or else you can make one more column with regard to class boundary and also it can be done. So the lower limit, if I reduce, it will be 0.5 and 9.5. I don't know whether it is clear or not. Let me redo once again. Sorry. Let me redo the problem once again for you. So let me calculate the class boundary here for example. So I'm making the class boundary here. So lower limit will be 0.5. 1 minus 0.5, 0.5. 10 plus 0.5, it will be 10.5. Same way, if you do for the next one, 11 minus 0.5 will be 10.5 and 20.5 if you add. Same way, 20.5 and 30.5. Then 30.5, it will be 40.5. Then 40.5, it will be 50.5. This is how we need to calculate class boundary. And if you reduce 0.5 lower limit and 10.5 upper limit, you will get the width 10. I'm just writing in bracket. Similarly, if you find for all, see it will be 10. First one is also 10, second one is also 10, third one is also 10, everything is 10. So this is the width we calculate from class boundary. So let me erase this example. Now let me do the problem for you. After this, it is very simple and easy to calculate the frequency density as well as the percentage frequency. Now I have erased. Now let me do the problem. Now, class frequency, as we know, it is 5, the first case, okay? So, 5 divided by 10 is equal to 0.5. The next one is 7. 7 divided by 10, 0.7. Same way, 14 divided by 10, 1.4. 18 divided by 10, 1.8. And 6 divided by 10, 0.6. So this is how we calculate frequency density. How do we calculate percentage frequency? Class frequency divided by total frequency into 100. Now class frequency is 5, total frequency is 50. See, I am marking here. So 5 divided by 50 into 100 is 10. The second is 7. So 7 divided by 50 into 100 is 14. Third one, see, it is 14. 14 divided by 50 into 100, 28. 18 divided by 50 into 100, 36. 6 divided by 50 into 100, 12. So if you make the calculation of the percentage, this total will be 100. So this is how we calculate the frequency density and percentage frequency. So I hope this simple example is clear to understand. Now let me explain what is cumulative frequency. Cumulative frequency is the running total of frequencies. What is this running total of frequency? Now let me try to explain. We have score, we have frequency. How to calculate frequency? First, we need to take 5 in the cumulative frequency like this. Second, we need to add the 5 with corresponding frequency which is below 5, 7. So 5 plus 7 will be 12. Next, 12 plus 6 will be 18. 18 plus 18 will be 36. 36 plus 14 will be 50. This is the example to understand with regards to cumulative frequency. It is nothing but the total of frequency and all frequencies below in a frequency distribution. Also it is called running total of frequencies. So I hope this simple example is clear. Let us do one more small problem to understand again. See in the given example, colors are given red, blue, orange, green, yellow. Frequency is given. We need to calculate frequency. As I told you, first we need to take 24. 24 plus 32, 56. 56 plus 10, 66. 66 plus 45, 111. And 111 plus 52 will be 163. So this is one more simple example to understand with regards to cumulative frequency. Now, what are the various types of cumulative frequency we have? We have only two. One is less than cumulative frequency and more than cumulative frequency. See the problem here, class interval will be given, frequency will be given. You need to calculate less than cumulative frequency. How to calculate? We need to focus the 10 upper boundary, that is we need to write here less than 10. First we need to write the frequency which is there given in the problem. Then we need to add 5 plus 7, we need to write less than 20, 12. You got the point? So 5 plus 7 will be 12 here. Same way, 12 plus 4, that is less than 30, 16. So this is how we need to understand with regards to the less than method of cumulative frequency calculation. So I hope this method is clear to understand. So they are arranged in ascending order of values or classes, that is from small to big. Frequency of all values or classes are successively added, including the value of the against which the cumulative totals are written. So it is a sum of all frequency for each value or class less than the upper limit of the classes. So this is the simple example to understand with regards to cumulative frequency. We need to focus on the upper boundary and we need to write those as less than. Okay. Then we need to take the first frequency. Then we need to add with the corresponding values. So this is how we calculate less than cumulative frequencies. Now, this is a simple same problem. Now we are going to do class interval frequency is given. The first frequency is 15, right? So 15 plus 10, 25. 25 plus 9, 34. 34 plus 8, 42. 42 plus 12, 54. 54 plus 14, 68. 68 plus 16, 84. It's very simple and very easy to calculate. So I hope this example is clear to understand. Now let me explain with regards to more than cumulative frequency. Same simple example I'm bringing. Now we need to focus on the lower value. We need to write more than 0. Okay, more than 0, we need to calculate the total. So if you make the total, this will be 16. So we need to start with 16 first. Then what we need to do, 16 minus 5. You got the point? So 16 minus 5 will be 11. Same way, 11 minus 7, you will be getting 4. So this is the value we need to understand with regards to the more than cumulative frequency. First, what we need to do, step 1 is easy, make the total of frequency. Okay, total of frequency is 16. So we need to start from 16 minus 5. So we will get 11. 11 minus 7, you will get 4. So with the last one, we have to leave it. This is the way we need to deal with more than cumulative frequency method. So they are arranged in descending order. Descending means from big to small. So this is what we need to understand. Frequency are derived by adding from the last frequency in opposite direction. That's why I told you we should make the total first, bring it on the top. See, in the opposite direction we are going on reducing and bringing the values. So it means we should start with the total and keep deducting the frequencies at each stage. Here the lower limit at each stage is used. So this is how we calculate with regards to cumulative frequency method type of problems. So I hope this example is clear with regard to this problem. Dear students, in the previous part, I had explained about broken-ended series, midpoint, cumulative frequencies and its types with simple problems and solutions. Now, in this segment, I am going to discuss about more than cumulative frequency, difference between less than and more than cumulative frequencies, grouped frequency distribution with steps, problems, and solutions. So, let me first discuss about more than cumulative frequency type of problem. Now, whenever you get more than frequency type of problem, you have to add the frequency. As you can see there, once you add the frequency, you will get the total. So that first total, how much you are getting, the same has to be started in the beginning of the more than frequency method by taking the lower limit more than 0. So when you make the total comes to 84. Now it is very simple. After getting 84, you need to reduce across frequency what is available. So 84 minus 15. So you will be getting for the next more than 15, 69. Similarly, 69 minus 10, you will be getting 59. 59 minus 9, you will get 50. 50 minus 8, you will be getting 42. 42 minus 12, you will be getting 30. 30 minus 14, you will get 16. So you can see in the end, this 16 and this 16 should be same. If it is the same, your calculation part is correct. So this is what you need to understand with regards to solving problem more than cumulative frequency method. So I hope this more than cumulative frequency type of problem is very clear with this example to understand. Now, let me make you understand the difference between less than and more than cumulative frequency. Now, you can see less than values as I am rounding it, and you can see cumulative frequencies are given. In less than method, we directly take the the lower limit value, that is less than 15. So we take the same 8. What we do? We add 8 plus 19, right? So this 8 we add with 19, the result is 27. Then 27 plus 22, you will get 49. 49 plus 27, you will get 76. 76 plus 32, 108. 108 plus 24, 132. Then 132 plus 7, you will get 139. 139 plus 1, 140. So this 140 and the frequency 140 is the same. Then your less than cumulative type of problem is right. Then in more than, you need to take the lower limit value. Start with more than 5. Okay. Similarly, whatever is there up to 75, we need to take. Now, here, what we need to take the total. Can you see here the total frequency? 140. So we have to start from 140. So after getting 140, 140 minus, you have to see the frequency here. Let me make you round. 140 minus 8, you will get 132. So 132 minus 19, you will get 113. 113 minus 22, you will get 91. 91 minus 27, 64. So 64. Like this, if you do, last you will get 1. Right? So this is the difference between less than cumulative frequency and more than cumulative frequency type of problem. So if you just understand, it will be much better to solve these two type of problem. Now, point to be noted here, in less than, we take the upper boundary. Okay, we take the upper boundary and we take the cumulative frequency and we add it to the corresponding frequency values, right? But in the case of more than, we take the lower boundary value, and we take the total of the frequency, then we subtract whatever is there on the frequency and we bring the value down. This is the method of doing problem with regards to less than cumulative frequency and more than cumulative frequencies. So I hope this example is clear to understand. Now, how to construct a grouped frequency table? I will give a simple example so that you can very clearly understand. Now, this is the table. The example states very clearly weekly wages for 15 workers in a company are listed below. We need to construct frequency distribution with 5 classes. See here, I am rounding. It is given very clearly with 5 classes. How many workers? 15 workers. So this has been given. We need to construct frequency distribution table. So how to do? Let me show you the steps. Now, step number 1 for this problem, what you are seeing on the right side is the problem, the same what I've shown earlier in my slide. Now, what is the step we need to do? We need to take the lowest value and highest value. Now, look at the problem. The lowest value is 10. Which is the highest value in the table given? The highest value is 34. So first we need to mark this. Then we need to find the range. So what is the formula for the range? Range is equal to highest value minus lowest value. As you can see, highest is 34, lowest is 10, the difference is 24. So after getting 24, how many classes we need to find? 5 classes. So what we need to do? We need to divide 24 by 15. So if you divide 24 by 15, you will be getting an answer of 4.8. So this 4.8 is rounded up to 5. Okay. So this is the point we have to keep it in mind while solving a problem. So these are the steps. So let us go to the further steps and understand how to solve this problem. So we got 4.8, we are rounding off 5. So rounding up is not the same as rounding off. I'm giving a simple example to understand. For example, if it is 85 by 6, please try to understand this is just an example. This is not connected with this problem. Okay, so try to understand this is just an example. Suppose you get 85 by 6, 14.167 will be the answer. If I say round off, you need to take 14. Rounded up will be 15. Okay, I will give you one more example. If it is 53 divided by 4 class, we will get the answer 13.25. Round off means you need to take 13. Rounded up, it means you have to take 14. So we need to tally the data and find the numerical frequencies from the tallies. So how to do? Let us see. Now I'm going to do the problem. Now first we need to identify the class limit. So how to identify the class limit? As usual, we know the lowest value is said to be 10. And already we found, okay, we found the answer is 5. That is we got for example, let me go back so that you can understand. As you can see, yes, as you can see in this, we got the class here, we found the range, and the question is asking 5 classes. So the class width we identified. See here, I'm rounding here. The class width is 5. Okay, this we have to keep it in mind while solving that problem. So let me go back. Let us go back to solve the problem. Yeah. Now we know the lower value is 10. So we got the class with 5. So 10 plus 5 will be 15. So what you need to do here, whatever value, for example, let me write on the top. 10 plus 5, we got 15, right? You need to write the lower value 10. Now the upper value you need to reduce minus 1. So you will get 14. So you need to write here 10 to 14. Now when you want to write the next one, you need to write 15. Okay. So 15 plus 5, 20. 20 minus 1, 19. Again, you need to start with 20. 20 plus 5 will be 25. 25 minus 1, 24. Next, you need to start with 25. 25 plus 5 is 30. 30 minus 1 will be 29. Then you need to start with 30. 30 plus 5 will be 35. 35 minus 1 will be 34. So I hope this is clear to understand. So let me erase everything so that you can understand. So I erased everything. Now this is the way we need to set the class limit. As I told you, first one 10 to 14, second one 15 to 19, third one 20 to 24, fourth one 25 to 29, and 30 to 34. Again, I repeat, first we know the lowest value is 10 and class width we identify it is 5. So I told you 10 plus 5 will be 15, but when you write the upper limit, you need to remember you need to minus 1. This is the rule. So 15 minus 1 will be 14. Okay. When you start the next one, you need to add plus 1, it will be 15. Similarly, if you identify 1, the next step is very easy. So 15 plus 5, 20. 20 minus 1 will be 19. So you need to start with 20. Similarly, you need to derive and identify the class limit. Now, class boundary, what is the rule? I told you. Lower limit, you need to reduce 0.5. Upper limit, you need to add plus 0.5. Now, the lower limit is 10. Can you see 10? 10 minus 0.5 will be 9.5. Then 14 plus 0.5 will be 14.5. See, this is the first answer. Okay. Same way, if you do for the second one, 14.5, 19.5. Then 19.5, 24.5. 24.5, 29.5. 29.5, 34.5. So I hope identifying class boundary is also clear to understand. Now we need to identify tally mark or tally bar. Now we will start the first one. Okay, we will start up with the first one. See, the first one is 10 to 14. So 10 to 14, see here, you need to look at the question on the right side. So this is the question. Can you see? I am rounding the question. Now from this 10 to 14, how many frequency is appearing? You need to check the total. See, the first one is only 10. So you need to write the tally 1. You got the point? And focus on the second one, 15 to 19. How much are you getting? See, we are getting 16 and we are getting the next one 18 and we are getting 19. So 3. So you need to write 3. Right? When you check the next one, 20 to 24, you see how many values are there? 22 values are there. Then we have 21. Then we have 22. See, 22. Right? Then we have 23 two times appearing. So totally if you count, this is 6. So you need to write like this and you need to cross, this is 5 and this is 6. Okay. Next, 25 to 29, how many values are there? we have 26. As you can see, I'm rounding. Then we have 27. Then we have 29. So we have only 3. Then remaining values 29.5 to 34.5, we have only 2. See, 32, 34. So this we need to write here like this. So this is how we need to identify and calculate tally bars. Okay. So I hope this step is clear to understand. Let me erase everything. So I will show you this is the way to calculate your tally bar. Now the next step is you need to write the frequency. Frequency, you have to write the number. First one is 1, second one is 3, third one is 6, then the next one is 3, next one is 2. Cumulative frequency is very simple. You need the first frequency, you need to write 1. Next one you need to add with 3. So 1 plus 3 will be 4. Same way you need to add everything and calculate the cumulative frequency. So let me show you clearly. First one is 1. 1 plus 3 will be 4. 4 plus 6 will be 10. 10 plus 3 will be 13. And 13 plus 2 will be 15. So this is the way to identify cumulative frequency. So I hope this problem is very clear to understand with regard to constructing frequency distribution with 5 classes. Now let me show you one more solved example. Okay. So here, this is the problem. In this problem, 20 workers in a company are listed below. You need to use 6 classes in order to identify the frequency distribution. Step number 1, very simple. You need to identify which is the lowest value. See, from the question, lowest value is 8. And which is the highest value? The highest value, if you see, it is 45. Okay, then we need to calculate the range. Then we need to solve as I have shown you earlier. It is the same problem. So we need to follow the same steps. We need to take the lowest and highest. Then we need to calculate the range. The range will be 37, and 37, if you divide by 6, it will be 6.167. We are taking the rounded up value, rounded up to 7. Okay. So when we take the rounded up value and then we calculate, this will be the answer for this problem. So class limit will be 8 to 14. So actually 8 plus 7 will be 15. 15 minus 1 will be 14, right? Then the next one, you need to start with 15. So 15 plus 7, it will be 22. So 22 minus 1 will be 21. Similarly, you need to calculate the class limit, and class boundary, the lower limit will be minus 0.5, upper limit plus 0.5. So 8 minus 0.5 will be 7.5. 14 plus 0.5 will be 14.5. So like that you need to calculate the class boundary, and tally you can look at the question as I am circling. So 7.5 to 14.5 you will have two value. Like this you need to calculate the tally bar. Then you need to calculate the frequency. Then the cumulative frequency. So if you do, this is the completed frequency distribution table. It will look like this. So I hope this problem is clear to understand with regard to frequency distribution table. In the previous slides, I had explained about more than cumulative frequency, difference between less than and more than cumulative frequencies, group frequency distribution steps, problems and solutions. Now, let me test you with some multiple choice questions and practice solutions and problems. Question number 1. When the tally marks are counted, it is called Any guess, dear students? Option A, class limit. Option B, class interval. Option C, frequency. Can you guess, dear students, which is the right answer? Yes, the right answer is frequency. Question number 2. When the number of observations are large, which of the following distributions is used? Discrete frequency distribution or grouped frequency distribution? Which is the correct answer? Can you guess, dear students? Yes, the answer is grouped frequency distribution. Now, question number 3. When the class limits 4.75555 and 8.85555 are given, then which of the following would be its class boundary? Whether it is option A or option B. I have taught this problem earlier and I have shown you how to use decimal places with 5, 0.00. So how many decimal places are there you need to use, and you need to reduce 0 0.5 in the lower limit and add the upper limit 0 0.5. How many zeros are there? Correspondingly you have to add and you have to do. So could you calculate and tell me, dear students, which is the correct answer? Whether it is option A or option B? Yes, the answer is option A, 4.755545 and 8.855555. Okay. Now let us move on to question number 4. The difference between the upper limit and the lower limit is termed as A class boundary, A class limit, B class boundary, C magnitude. Which is the correct answer? The answer is magnitude. Now, question number 5. The difference between the upper boundary and lower boundary is termed as A class limit, B magnitude, C class interval. What is the correct answer? Yes, the answer is class interval. Now let's move on to question number 6. If the class limits are 50 to 60 and if the number 60 is not included in it, then it is called inclusive class interval or exclusive class interval. Which is the correct answer? It is very simple. The last number 60 from the class limit 50 to 60 is not included. Whether it is inclusive or exclusive. Which is the correct answer? Yes, the answer is exclusive class interval. In exclusive, the last number is not included. If you include the last number, it becomes inclusive class interval. Question number 7. Which of the following is the correct formula for calculating percentage frequency? Class frequency divided by width, class frequency divided by total frequency into 100. Which is the correct answer? Could you guess, dear students? Very simple. It's given percentage. Percentage means the answer will be yes. Class frequency divided by total frequency into 100. Option B. The following frequencies are provided to you, that is 587. You need to find what is the value of x as I am circling it. The cumulative frequency is given as 25. See, this is the cumulative frequency value. Then What is the value of x? X will be 0, option A. X will be 7, option B. X will be 5, option C. How to calculate? See, it is very simple problem. 587. You need to make the total. So 5, that is 8 plus 7, 15. 15 plus 5 will be 20. And our cumulative frequency is 25. So 20 minus 25. Very easy, dear students. What is the answer? 5. The answer is 5. Okay, now let us move on to discuss some practice question problem. This is a simple problem. The human resource manager of a large company commissions a study in which the employment records of 500 company employees are examined for absenteeism during the past year. The business researcher conducting the study organizes the data into a frequency distribution to assist the human resources manager in analyzing the data. So he has analyzed the data like this as I am circling. Now you need to answer the questions. Three questions are given. Why does the business researcher construct the frequency distribution? Okay, this is question one. What is the rule of thumb to select range of classes? Comment the reasons. This is question 2. Determine the class midpoint and the cumulative frequency for each classes of the frequency distribution given. This is question number 3. Now let us see how to solve these questions one by one. Now the business researcher uses frequency distribution. The first question, this is the answer, as it is a useful tool to present summary of data in the form of class interval and frequency, which enables the study of data collected at a single glance. So this is the answer to the question 1. And question 2, one rule of thumb is to select between 5 and 15 classes. If the frequency distribution contains too few classes, the data summary may be too general to be useful. Too many classes may result in a frequency distribution that does not aggregate the data enough to be helpful. So this is the answer for question A and B. Question C is what we need to see how to answer. Now, this is the question from the previous question. I brought it here below. Let us solve the answer. We need to write the class interval and frequency from the question as given. We need to calculate the midpoint. Midpoint, we have formula lower limit plus upper limit divided by 2. The first lower limit is 0. The second is 2. So lower limit plus upper limit divided by 2. 2 divided by 2 will be 1. So first we need to make the total of frequency. Then we will start the class midpoint. So the answer will be 1 for the first. The second it will be 3. The third one 5. The fourth one 7. The fifth one will be 9. And we need to calculate the cumulative frequency. First we need to write the frequency here which is given 218. Then 218 we need to add 207. So if we add how much we are getting? 425. Same way 425 plus 56 481. 481 plus 11 will be 492 and 492 plus 8 will be 500. So this two will be same. So this is the answer for the third question. Now let us see the next question. So this is a question actually two, that is selling price and frequency will be given. We need to calculate the relative frequency. And three questions are given below. So how to find relative frequency? First, we have frequency 8. Then we need to make the total. The total is 80. So 8 divided by 80, it will be 0.1. That is the first answer. Similarly, second will be 23 divided by 80. So 0.2875. Like that, we need to calculate the relative frequency. Okay, do you understand, dear students, how to calculate relative frequency? How it is found? So here the solution is given. Now we need to answer three questions. Let me bring it to the next part and explain you very clearly. Now, referring to the table 2 to 5, which shows the relative frequency for the vehicle sold last month at Whitner Autoplex, we need to answer three questions. First question, how many vehicles are sold for $18,000 to $21,000? See here, the question here, 18 to 21, how many? How many we are having? It is 23. This is the answer. Now, question number two, express in percentage. Percentage means we need to multiply by 100. The number of vehicles which were 24,000 to 27. See here. So, you can see the relative frequency. Relative frequency is 0.2250. With this, we need to multiply by 100. So, if you multiply by 100, it will be 22.5 percentage. The third question, what is the percentage of vehicles sold 30,000 or above? Now you can see here 30,000 and above. It is from here, this 2 point. So we need to add these two, then we need to multiply by 100. So if we add these two and multiply by 100, it will be 7.5%. So this is the answer to this question. So I hope, dear students, you have understood this problem clearly. Now these are the reference links available in ProQuest. If you have any doubts, any queries, you can contact your concerned course lecturers and clarify your doubts. With this, chapter 2 is over. Thank you.